Now, we shall be looking at how to find the product and sum of roots of a quadratic equation. And before we proceed, please subscribe to this channel so that you will be notified when new video is uploaded. Now, let us consider the general form of quadratic equation . Now, let us consider the general form of quadratic equation ax squared plus bx plus c is equal to 0. If we solve this quadratic equation using completing of the square method, then we derive the formula x is equal to minus b plus or minus b squared minus 4ac over 2a. Now, and this one, it simply means our x is equal to minus b plus b squared minus 4ac over 2a, or our x is equal to minus b squared minus 4ac over 2a. Now, the meaning of this equation, that is the plus or minus we are having at the middle here, is just this one. You can just break it and write it in this one. Now, supposing the first root is represented by alpha and the second root is represented by beta, and let d represent what we have inside the square root, that is b squared minus 4ac. Therefore, our alpha will be equal to minus b plus root d over 2a, and our beta will be equal to minus b minus root d over 2a. I mean, if the first root of the equation is represented by alpha and the second root of the equation is represented by beta, if we represent what we have inside the square root as d, which is b squared minus 4ac, then our alpha will be minus b plus, what do we have inside the square root? D, which is equal to d over 2a, and likewise for our beta. Now, to now find the sum of the roots, then we have alpha plus beta. We have alpha plus beta. And what is alpha? Our alpha is minus b plus root d over 2a plus minus b minus root d over 2a. Then, what do we have as our LCM? We have 2a. Then 2a goes in 2a one time. 1 times what we have at the numerator. Then we have minus b plus root d, minus b plus root d minus b minus root d. Then this one will give us minus b will give us minus 2b minus root d plus root d. That one will give us 0. Therefore, we have minus 2b all over 2a, and alpha plus beta will give us 2 will cancel 2. Then we have minus b over a. Then we have minus b over a. That is the sum. That is the formula for finding the sum of roots of the quadratic equation. Now, if we want to find the product of the root, this one will be alpha times beta, and this one will give us What do we have as our alpha? We have minus b plus root d over 2a multiplied by minus b minus root d over 2a. Now, if you multiply this together, then we have denominator minus 2a times 2a. Then we have 4a squared. And at the numerator, we have minus b plus root d multiplied by minus b minus root d. So if you open these brackets, then we have minus b times minus b. We have b. We have b squared. We have b squared. Minus times minus will give us positive. So that b times b give us b squared. And minus b times minus root d. This one will give us b root d. Then minus b plus root d. This one will give us minus b root d. And root d plus root d times minus root d. This one will give us minus d. How do we arrive at minus d? You know, we have a root d times root d. This one will give us root d times root d. And this one will give us root d squared. The square root will cancel the square. Therefore, we have d. Now, to continue with this, 1 over 4a squared. Therefore, we have plus b root d minus b root d to cancel each other. Therefore, we have b squared minus d over 4a. And if we recall, I said our d is equal to b squared minus 4ac. Therefore, our alpha and beta give us b squared minus b minus 4ac all over 4a squared. 4a squared. Now, this one will give us b squared. If we open the bracket, we have minus b squared minus times plus will give us minus times minus will give us plus 4ac over 4a squared. Therefore, we have plus b squared minus b squared will give us 0, and we have 4ac over 4a squared. Now, alpha times beta will give us 4 will cancel 4, and 1a at the numerator cancels 1a at the denominator, so that we are left with c over a. And that is just the formula for finding the product of roots of a quadratic equation. Now, before we proceed, let us look at the application of this root. Now, to look at the applications of this root, let us consider the equation 3x squared plus 5x minus 10 equal to 0. Now, if we relate this one to the general form of quadratic equation, which is ax squared plus bx plus c equal to 0. Now, we discover that our a is equal to 3, our b is equal to 5, and our c is equal to minus 10. Now, the next thing we do to find the product, therefore, the product of the sum. Let us look at the sum of the root. The sum of the root will be alpha plus beta, and this one will give us, what is alpha plus beta? Minus b over a, and this one will give us, what do we have as our b? 5 minus 5 over, what do we have as our a? We have 3. Therefore, our answer is minus 5 all over 3. Now, if you like, leave it this way, and if you like, you write it in a proper fraction. And this one will give us 1, then 2 over 3. That is minus 1, then 2 over 3. And to find the product, of the root, which is alpha times beta. What is the product of the root? That is c over a, which is equal to c over a. This one will give us, what do we have as our c? Minus 10 over, then our a is equal to 3. Therefore, we have minus 10 over 3. You can also write this one as a proper fraction, and we break it as minus 3, then 1 over 3. At least 3 goes in 10, 3 times, so mean 1, and it's 1 over 3. Now, this formula we just derived is used when you are given an equation and you have to find the sum of its roots and the product of its roots. Now, let us look at another one. Now, there's a situation whereby you can be given ordinary root of a quadratic equation and you'll be asked to form the equation whose roots are those given. Now, supposing we have supposing alpha and beta are the roots of a quadratic equation. Now, supposing alpha and beta are the roots of a quadratic equation, therefore it simply means our x is equal to alpha, or our x is equal to beta. Now, if we move this one inside, then we have x minus alpha is equal to 0, or x minus beta is equal to 0. Therefore, we have x minus alpha, x minus beta is equal to 0. Now, if we open this bracket, then we have x squared minus alpha x minus beta x plus alpha beta. That is, this times this will give us this times this give us this times this give us this, and this times this will give us this one, equal to 0. Now we have x squared minus alpha, open the bracket, this times this will give us positive beta, then factorize, the x will be outside, plus alpha beta equal to 0. Now let us call this one equation 1. Now let us look at the general form of quadratic equation I wrote for you earlier, which is ax plus bx plus c equal to 0. Now, if you are given any form of quadratic equation with the coefficient of a squared more than 2, now the first thing you do is to divide the whole times by what you have as the coefficient of s squared. Now, what do we have as the coefficient of s squared here? We have a. Therefore, divide both by a, so that we have s squared plus b over a x plus c over a equal to 0. Now, let us call this the second equation. Now, what we need to do next is to compare equation 1 and equation 2. Now, compare equation 1 and 2. Now, if we compare equation 1 and equation 2, we discover that we have s squared here, then what is the coefficient of x? B here, then minus alpha plus beta, our c, which is c over a, alpha beta. Now, we realize that minus alpha plus beta is equal to, what do we have here? B over a. Therefore, alpha plus beta is equal to minus b over a. And this one gives us what? The sum of the roots of a quadratic equation. And if we also compare what we have, the third term, then we have x times b equal to, what do we have here? C all over a. Now, you can see we've already derived this. Now, let us look at one application also on how to use this one. Now, supposing you are given an equation 5x squared minus 7x plus 14 is equal to 0. Let us assume you are given, okay, let us look at one application of this. Now, form a quadratic equation whose roots are, let's say, half and 7. Now, let us assume we are given two quadratic equations, or let us write this one. Let's say we are given 3 and 8. Now, let us assume the two roots of a quadratic equation are 3 and 8, and we are asked to find the equation whose roots are this. Now, to solve this, then we say, supposing alpha and beta are the roots of the equation. Therefore, if alpha and beta are the roots of the equation, then we say, let alpha and beta be the root of the equation. Let alpha and beta be roots of the equation. Now, if alpha and beta are the root of the equation, then we have our alpha to be 3, equal to 3, and our beta to be equal to 8. Now, our beta will be equal to 8. Now, to solve this, what we do is to write this equation out. What do we have at that equation? We have s squared minus alpha plus beta x plus alpha beta equal to 0. So what we need to do in this case is just to substitute the value for alpha and the value for beta. Now, by so doing, we have s squared minus, what do we have as our alpha? 3. 3 plus our beta is 8, x plus alpha beta, that is 3 times 8 equal to 0. Now we have s squared minus this plus this will give us 11x, and this times this will give us 24 equal to 0. So this is the equation whose root is 3 and 8. Now let us quickly look at another one. Let us assume, second example, you are given if form the equation whose roots are, let's say, minus 3 over 2 and 4, whose root is minus 3 over 2 and 4. Now, we say let alpha equal to minus 3 over 2 and our beta will be equal to 4. Now, to now substitute, let us write the general form together, which is a s squared, which is our formula, minus